Good afternoon, my name is Michał Strzeszewski and I will be your host at the presentation of Audytor H2O 1.5 software. The software is dedicated to the computer-aided design of internal water supply systems, including cold water, hot water and circulation pipes. And the main method of designing the system is using the diagram, a diagram of the water supply system, and this is the main basic and obligatory drawing for the design. At the same time, it's possible also to prepare the plan views and present the results of calculations on the plan views. However, this is not obligatory. The way of preparing the plan views is that way that you draw the system as well in the plan view, and then you will associate the appropriate elements of the plan views with the elements of the diagram. However, note that it's obligatory only to associate the elements that you would like to attach labels. For example, this pipe has got a label, so we have to associate that with the appropriate pipe in the diagram, and then after calculations, here the program can present the results of calculations, for example, the diameter, the selected diameter of this pipe. But if you have some pipes that hasn't got labels, you don't have to connect them. Let me first show you some examples of the designs that are attached to the software. The first example is the design of the simple water supply system. In each apartment you've got a bathroom and appropriate appliances, and also a few appliances in the kitchen, and this is the supply to the apartment. You've got the meter to measure the amount of water consumed. These are here the risers of the building, and the red one is, as we can guess, the riser with the hot water, blue one with cold water, and here with the circulations pipes that would circulate the water in order to maintain the appropriate temperatures. And if we go down at the bottom of the riser, you can see the thermostatic valves that would control the flow through the circulation pipes in order to limit the unnecessary circulations. If the temperature is high enough, it would limit the flow. If the temperature drops, it would open and let water to circulate to maintain the appropriate temperatures. Example 2 is very similar, so let me show you example 3. This is the example of manifold, or in the other words, distribution system with distributors. We've got here the distributors, this one, the distributor of cold water, and here the distributor of hot water, and then the connection pipes to the appropriate receiver. The way to do it is that we draw the horizontal pipe, which is in the floor in most cases, and we draw only very short element, only short pipe. However, if we select this short pipe, in the table beneath we should write the full length of this pipe. And then we connect these pipes with so-called connectors of distant pipes. And this is the way of designing the manifold systems. Just note that for this element, connection of distant elements, distant points, the program appropriately takes into account the vertical length, the length between the outlet of the distributor and this point in the floor. However, it doesn't include any horizontal length, but all the horizontal length must be entered here. It's 1 meter, for example, here 2 meters, and so on. You have to write it appropriately. Then, if we have a look at the drawing with the from the fourth example, this is the example of the local hot water preparation. So we've got only cold water risers. We have neither hot water risers nor circulations, and we've got, for example, a gas heater here in the apartment. Such systems may be also designed if necessary. And the last example is an example of a very small system in a one-family house, but it's an example of preparation both the diameter, the diagram as well as the plan views of the floors. And the other basic principle is that in the software we use two sets of drawings. All these drawings that I have been showing you so far are the drawings with data. And you can see that easily if you have a look at the labels. In this case, the program already knows that the length of the segment of pipe is 3 meters and 5 centimeters. However, the diameter is cal dot. It means that the designer didn't enforce any specific diameter, but just let the program select the diameter. So we've got this information that it should be selected by the software. And now, if we run the calculations, for example, using this calculator button, now we can switch into the drawing with the results. I can do that very easily using the Control tab. So let me show you maybe again the similar part. It's good to have this option on, like the synchronizing the drawings with the results and data. So after changing, you can see the same part of the drawing. So again, this is the drawing with data, and this is the drawing with the results. You can, for example, already check the selected diameters of the pipes. If necessary, you can also add other information in the labels, but this is the basic solution. So that was the introduction to the possibilities of the software. Now let me show you how to use the software. So let's design a little part of the system. So we'll start the new data with the file menu. So now we have the new data, and we'll start with the global data. So if we go to the data menu and now choose the general, it means that either general or the other name is global data. First, you can write some information about the name of the project, the locations, and so on. Also, you may include here your name. And then there are some basic information like the temperature of cold water, let's say 10 degrees Celsius, and then the temperature of hot water. However, here you have two values. The first value is the hot water leaving the heat source. So it means that, for example, we wish to be able to prepare the hot water at a temperature of 60 degrees Celsius. However, later on, as the water flows through the pipes, it cools down, and we have got the required temperature at the valves, at the taps. So, for example, 55 degrees Celsius. And then we have to also select the type of the building. This is very important information because depending on the type of the building, the program would then estimate the design flows for the common pipes. If the pipe supplies water to more receivers than one, then typically the design flow, it's not the sum of all the outflows from all the receivers, but it's reduced. And the way of reducing depends strongly on the type of the building. So, for example, multi-family apartment building. And then, in this form, we have to select the pipes. We can select the several types of pipes and associate them with the letters A, B, C, and so on. To select the pipe, I have to click here, this black triangle, or a kind of arrow, as some people prefer. And now I will press Edit. And the catalog of pipes appeared in the screen, and I can select any pipe. So for this presentation, I just selected a random pipe. And now I have to copy that to the right panel where I have the selected pipes, and now I can press OK. As you see, nothing happened in this screen because what I have done so far, it was adding the pipes to the available pipes, and now if I pull it down, this button again, now this pipe is available for me. And if I am in the first row in the upper table, the lower table presents the available diameters and other data associated with the diameters. These are the standard data. In most cases we don't change that. However, if necessary, if justified, it's possible to change them. And probably the most common data that you may change here is the first column. It's the information whether the diameter is available. It means whether we wish the program to be able to select. By default, as you see, all the diameters from 16 to 110 are available, but if because of any reasons we don't like to select the diameter 16, we can exclude it. If I pull it down, select No. Sorry, let's try again. So now if you can see that there is no check mark for the diameter 16 in the first column. It means that now this diameter is not available, the program won't select it, so the selection will start from the 20. The smallest diameter selected by the program will be 20. And in this way you can make not available not only the smallest or the highest diameter, you can decide on each one whether it should be available or not. Let's come back to yes. Now again all the diameters are available. There is also, the program reminds us to save our design. I think it's a very good idea. And as you see, in this form, in global data, we have also the second tab. It's called calculation parameters. And these are the parameters influencing the selection of all the elements, all the calculations. For example, First, we've got a group about hot water and circulation. The first option, estimate calculation flows beyond heater, this local heater according to German standard DIN. This concept says that if we've got the local gas heater, we select the flow through this heater using the maximum flow from any receiver. So the program is looking for the receiver with the highest flow, and it's just designing the standard way that it's available, it's enabled to heat up water only for this highest flow rather than the sum of outflows. And the following options have got the appropriate meanings. General advice, general recommendations like that if it's necessary and if you understand the appropriate option, feel free to choose it. If you are not sure, then we would recommend rather to keep this standard default set of options. So let's say that we'll do like that in this example. So let's press OK. And now for the diagram, we would need the system of floors. Systems of floors we will create with this button. So we are in the construction tab, and the second button will start the wizard to create automatically the system of the floors. So let's press it. And let's say that in our design it would be enough to have maybe 3 stories, and the length would be, for example, 30 meters. Of course, the horizontal length doesn't have the literal meaning in the diagram. However, the program must draw something shorter, longer, therefore we have to write, but it's just the meaning of our drawing of the diagram rather than any 30 meters in reality in the building. And then we have the story height, which is 3 meters, we can change it if necessary, and the thickness of the floor 30 centimeters. And we will use this information if we have all the floors of the same height. If it's not the case, we can use this table here, and then we can specify the height of each of the story separately. And also it's good to keep this option on to have the ordinates of the on the floors. And if you are ready, we can press OK. Now the newly created system floors have been put into the clipboard. You can see the shape of the cursor, that we've got something in the clipboard and then we can enter it. So let's press it, and now we can see only a small part of the ceiling of the system. So let's press Ctrl Z. Ctrl Z makes the whole drawing available. So this is what I created. You can see also the ordinates. This ordinate is 0.00 and it's red. It's red to show that this is so-called reference ordinate. Wherever we put this ordinate, we say that here it's the level 0. It says it's maybe funny plus 0, but it's the same, just 0. And if we say that this first floor is in fact in the basement, that is a little bit under the ground, and we would like to have the 0 on the first story that is fully over the ground, so we have to exchange it. And the way to do it is very simple. We just have to drag it a little bit higher, and we just exchange. And now I say that here it's 0. 0 it's on the second floor, counting from the bottom. And as you see, if I changed the ordinates, this ordinate here underneath says -3. So the rule is that wherever we put this red ordinate, we decided here it's 0, and all the other ordinates just adapt themselves appropriately. And also the consequence of that rule is that you may have only one reference ordinate, this red one, in the diagram, because you can have only one 0 level, and you can have as many as you wish other ordinates. So as you see here it's -3, then it's 0, and here it's +3. What we also need the room zones. So I can select this first command, room zone, and now let's draw a room zone. Here we may have the cellar, so basement, so it can be pretty big. And next we can have something smaller. And if I select all the room zones, and if I go to the room zone tab in the table beneath, I don't know if you can see, there is a table, but just empty, and these lines are just very light gray. So what I can do, I have to write here the appropriate information. Also what's important is if I navigate through this table, the appropriate room zone highlights in the diagram. So for example, this one is basement, so let's write the symbol basement. You can write either numbers, digits, or the text for the symbols. However, it will be in the capitals. And the temperature, for example, +8, and we can also describe it somehow. And then this would be 1, temperature 24, and that would be a bathroom. And maybe here room number 2, and that would be a kitchen. You can also write some remarks if necessary. You can access this information also from the data menu using command rooms, and if it happens that you have done the heat calculations of the building using the Audytor OZC, or in English Audytor HL software, so you can import all this information. You would have already the symbols of the rooms and their design temperature. The design temperature is basically to design the heating system. However, it's also used in Audytor H2O in order to estimate the heat losses through the pipes. So you can either enter this data automatically, or you can import that from the results from Audytor HL software. And now let's put some receivers. So in the bathroom we probably would need a wash basin. You can use either the general wash basin or the wash basin with appropriate diameters. These diameters may be useful if you also prepare the planned use, because then the program would place the elements of the appropriate size. If we prepare on, like in this example, the diagram, so we can just select a wash basin, and then we can copy, and then pull it down again, and then we can select it. The program also suggests and snaps to the appropriate height, if we wish to put it on the standard height. If not, we can move it. And okay, then we need also some taps, some faucets. And there are different types, so depending on what we wish maybe the standing one I would select. This is for billet, so maybe for wash base, maybe this one. But this is just an example. So you have to go to the software and try to play with it and see what are the possible elements to use. Sorry, it's here. Okay, so we've got a wash basin. Probably would need a toilet as well. So again, we have to select something. And what I'm selecting, these are just examples. Then a flush tank. And probably we also would need a shower or a bath tube, depending. So here it says maybe a little bit fun, it's a swimming pool, but it's not a swimming pool. In fact, it's this pool, this spot for the shower. And now we have to put the appropriate faucet. So we have to look for something that is for the shower. For example, this one. And then if we place it, also the program snaps to the appropriate height, appropriate level. And then probably would also need a washing machine. These are just some examples. As you see, there are many more appliances and receivers available. And also we would need a sink in the kitchen. These are just wash basins, so let me see. Here we've got sinks. So let's, I would just select the first one available. So this is, let's put a sink, and also would select the appropriate faucet. And this one works with, sorry, not at this place. Yeah, I just put it in the wrong place. So maybe the easiest way is to delete it and to place it here as well. And maybe a dishwasher. It's a good idea for a kitchen. Okay, so we've got the water receivers. Would also need then pipes, and we would need also a heat source to prepare the hot water. If we prepare hot water inside the house, which is mostly the case. So for the heat, so we've got, let's have a look what we've got. We've got a boiler, but for our system we would use an accumulator. You can say that accumulator is not a heat source as such, it's rather to accumulate the heat, but from the design of the water supply system, we may treat it, and we do treat it as the heat source. Of course, it must be supplied by some external source, for example, a gas boiler, but we don't design that in this design. We just design the water system, so we treat a water accumulator, water tank, as a heat source. And now let's draw the pipes. So I have to go to the pipes tab. And let's start maybe with the hot water. So if I pull it down, as you see, this is this first A type, and then I would connect hot water here. That would go until the kitchen. Let me see what I have to connect. Also, I have to connect the shower. And I think for hot water, that's all. I need a little bit more for cold water, because more appliances would use cold water. And also, I have to go to the dishwasher. Also, the washing machine. And also the toilet. So these are these main these pipes in the apartment, and now we have to connect it to the water tank. As you see, if I come to the water, the program shows me and maybe I will connect first the hot water. Program shows me the possible connection point of hot water. So this is connection to hot water. Cold water would come from the external source, but I have to connect cold water to the water tank. And that pipe would bypass the tank. And also I can connect the circulation pipes. And let's say you've got the connection of the circulation pipes. And the other element that I also need, this is the water source. We have to have some point where we enter the water in our system. This is in this first time water sources. And as you see, there are a few combinations. I will use this first one because I am preparing everything within my apartment, within my house, sorry. So I need only cold water. Hot water I can prepare inside my design. However, it may happen, especially if you design only the part of the system, for example, only in one apartment, that you can use a set of both hot water and cold water sources, or even all of them, including the source. In this case, will be not an outlet of circulation. This is to design only the elements, only the parts of the system. But in this full design, we need this first one, water source. So that is my very simple the diagram of the system. What I also have to do, I have to enter the lengths of all the horizontal pipes, because for the vertical pipes, like this one, the program can read the length from the diagram, and if we say that this what we have drawn here is precise enough, if the differences between the joint realities are just a few centimeters, we can say that's okay. So, for example, if I select this pipe, the program already says in the green font that the length is 30 centimeters. And if we say that it's precise enough, we can just leave it. But for the for the horizontal pipes, the program also reads from the diagram and says, for example, in this case, it's 2 meters, 55 centimeters. But in most cases, this values read from the diagram won't be true, won't be correct for the horizontal pipes. So for the horizontal pipes, you should here enter these values manually. For example, 2 meters. I won't do it for all other pipes because this is just an example, but it's important that you do. unless you believe that it's precise enough. For example, for this pipe it says that it's 1.2 meters. If you say that even it's not precisely 1.2, but if it's close, you can say, you can leave it. But the general principle is that the designers enter the length of the horizontal pipes and don't enter them for the vertical pipes. Because we would like to have later on the drawing with the results and with some information, so it's recommended to attach some labels. The labels are in the construction tab here. And if this is this last object, component label, I can attach it also to the receivers, but especially important is to attach labels to the pipes, because in this way we can present the diameters, if necessary also other information, but first of all I would say diameters of the pipes. I would just put some of them as an example. Maybe I would attach it also to the water tank, maybe this one. And also it's reasonable to attach a label to the water source. And now let's try to calculate this system. The program would check whether the data are complete, whether it's possible, and if it's possible, the program will run the calculation. So let's press this calculation button, or let's press F9. And actually it's not possible. There are some errors preventing, which is very often the case. Yeah, if you design something, it's very hard to remember about everything, but it's not a problem because the program reminds us. And let's have a look. Heat source, the receiver. Yes, that's right. I entered the accumulator, but I didn't enter any information. I have to enter manually at least the resistance of the flow. Actually two resistances, one for the hot water and the other for the circulation circuit. So we can enter the resistance of the heat source in three possible ways: as the kV factor, or as the specific pressure drop in Pascal, or zeta coefficient. The pressure drop in pascals may be the most precise if we know it, but of course we can establish that precisely later on if we have the flow, because of course the resistance depends strongly on the flow. More general solution is to enter the kV factor if we know it for the specific appliance. Let's write 6. Just as an example, I would write both kV 6. There are also some other data, but they are taken automatically, and we can change the, if we don't change it, the program just would take the appropriate, the default data. So now let's start to recalculate, and now there haven't been any errors disabling the calculations, so the program has done the calculations, and after that the program also does the diagnosis of the system, and that results in this list of errors. However, as you see, the majority of these messages are not errors in fact, but warnings. This is what I said, that the program just recognizes that this is the horizontal pipe, and the program may take this length from the diagram, but most probably that won't be correct. So the program just warns us whether we are sure that it's okay, whether we wish to, or maybe that we would prefer to write the appropriate value. Also, the program and warns us that probably we should have some isolations. Also, we can have a look that there is information about the low water velocity, so that we can consider a pipe that's got the lower diameter. However, in this pipe, 16, it's just the lowest available. And the only red, so more serious mistake here noted by the program is that there is a very large number of the hot water exchanges, so a lot of water flows through the circulation. It's 17, more than 17 times per hour the water exchanges in this pipe, where the warning point is 4. It's no wonder because we didn't put any valves. If we put here the thermostatic valve, that would stop this problem. But I'm just showing you that in order to show you this diagnosis possibilities. Just please distinguish two diagnoses, because before calculations, the program does the diagnosis of the data, and in order to fulfill the calculation, to carry out the calculation, we must eliminate all the errors preventing calculations. If there are no errors in data, then the program does the calculations, and after calculations, the program analyzes the results. So now this is the diagnosis of the results, and as a result of this analysis, the program presents the list of possible errors or warnings or other messages. Now let's have a look at the results, because still this is the drawing with the data. If I press Control Tab, I would have the drawing with the results. So as you see, we can now see the diameter selected, 16, but for example for the shower it's 20, and if we go to the main pipe it's even 32. Yeah, and the main pipe from the water source is 32. We have also the required water pressure at the heat source, and we have also the critical branches shown. So it looks that the critical branch is to this receiver, to the shower. So this is the presentation of the results in the form of drawings, but we can also see it in the form of tables. So if we have a look at the results menu, so there are a few commands with different sets of results. First, we've got the general or global results, which has got the most synthetic information about our system. For example, the necessary pressure, available pressure for water at the beginning, at the enter point of the system. And then we have also pictures for the pictures, for the drawings, pretty important, small but very important water source. So we've got here the information about of the water source, of the specific information. We have just one water source, so there is just one row in this table. And then about the heat sources, also we have got one heat source, so one row. Also about the pipes, this table is typically quite long because it's got just sets of the pipes, so maybe it's better to observe this table not here as a separate table, but in the connection with the drawing. You can see this result table also here in the table beneath the drawing, and have a look that it's dynamically related. If I go through the table, the appropriate element highlights in the drawing, and the opposite if I select the appropriate pipe. So then I can read in the table the information about this pipe. Yeah, the length, diameter, also the flow. For example, here we've got the sum, the total, and then this calculation flow. As you see, it's results. So the sum of all the receivers for this specific pipe is 0.35 liters, but after reductions 0.29, because we assume that statistically not all these receivers would work at the same time. So this table, I would rather say that it's rather to point at the drawing and then read the table, the information about the selected pipes, rather than analyze it as a table. Then we've got also the sets of all the receivers. Then about the accessories, I didn't put an accessories and valves yet, so this table is empty, but normally would have some results here. Also about the rooms, so this doesn't tell us that much, it's just a set of the rooms. And to analyze the system, rather the next one, the branches. The branches is more useful because in this case you have got the pipes, but not just a set of pipes without any logics, but we've got the branches. And then you can analyze the pressure drop in the branch. For example, here we've got the branch to the critical receiver, and that can tell us more. We have also the similar sets for the circulation circuits. And then the presets, if we have got an accessories with the presets, then we can have the error list that you have already seen, and then we can have the sets of the material. So these are a kind of shopping list that is just grouped according to the materials rather than because according to any branches and so on. And at the end, just let me show one more interesting possibility of the software. This is the editing of the styles of the label. If you have a look here at the drawing with the results, this is the label for the pipe, and we can read just the diameter and the thickness of the wall as the part of the diameter, and that's all. But we can change the style of this label. If I double click the label, such a form opens. This is the editor of the format. Then I have to as you see here, there are also other information, just it's not available for this pipe, therefore it's not presented. But let me add something. For example, dP, this is the pressure drop. If I put it, for example, here, I can put it just like one value, or I can write something before, for example, dP. I can include the units to make it more clear, and I can select the kind of form. And now if I close it, you can see that some other elements, this element was added. The pressure drop just, I think it's rather not in pascals, it's probably in meters. And to make it more consistent, I also will change the frame here. So now my labels look like that. So this is the very powerful tool. It just let you present the information that you think that for the specific purpose are reasonable. As you see, the possible available elements, you have really a lot of information. Of course, which are not reasonable to put all of them because it will be very unclear. But depending on the purpose, you can use different elements and present it in the diagram. So that was the presentation of the Audytor H2 program. Thank you very much for your attention.